Hi, this is Greg with an introduction to material requirements planning. This is a companion video to the overall planning system video that you hopefully have viewed before this one. In that other video was that diagram of the inventory levels of a component as you go through time, and the withdrawals happen in large quantities, so the reorder point system doesn't work very well. We need another way to trigger reorders, so we're going to talk about material requirements planning and how that might work. Remember from the last time we saw the example of the pumpkin bread and the different materials that were in there and the methods, etc. And so we're going to continue talking about MRP, but we're not going to stay on that same example. We're going to use a different one as we move through. We're not going to talk about 4S either, the iPhone, but you can again see all the components here, and then there's a bill of material associated with that product, and you can see the major cost drivers there in the left-hand column: memory, the display, touchscreen, the processor, the camera, the wireless technologies, etc. All those components that go into or went into the iPhone 4S, because I think they're making iPhone 5s now, not the 4S. So here's another example of bill of material. In this case, the end item, the parent item, is a shoe. And then on the left-hand side, you can see all the different components that go into that particular shoe, different accessories and ribbons and heel and sole and toe cap, etc. In different categories, and across the top of that matrix, category items variant, and then you get to quantity over there. So just again, another picture of the bill of material, as we talked about before. It's basically the recipe for how to make the finished good, the end item. So here's the example that we're going to work through. And this is going to be a chair. So at the very top of this is the complete chair, the parent item. And we're going to call that item H. And you see for each of these then there's some nomenclature. The lead time to assemble chairs, assuming we have all the components together, meaning an F and a G, is 1 week. And the item description is a complete chair. Now to make a chair we need, at the next level down, 3 things. We need F, which is the seat front legs subassembly. We need 1G, which is the backrest rear legs subassembly, and then we need 4 of E's, which are fasteners, and you can see in the parentheses are the quantity required. Remember in the pumpkin bread example, 200 grams of flour, so we might say 200 grams in that, in the parentheses. Then those subassemblies, those level 1 items, are made up of some items that go into those, and those are the level 2 items. So you can see that the F, the seat front legs subassembly, is made up of an A, an E, and a C. Actually 4 E's and 1 C. Front legs, then fasteners, we need 4 of those, and then 1 seat. Those things are combined into that subassembly as well. So we're going to continue working through this bill of material, and I see how the math works in MRP. So in the upper left is that same bill of material that we just looked at. On the right-hand side is the overall planning model that was introduced to you in the planning video, and that comes from the Barry Weibach book, and it's been around for a very long time. And then there's the picture of the shoe bill of material that we saw. So in that overall planning and control system on the right, the bill of material, those are the ingredients, right? So the ingredients for the shoes in that box, the ingredients for the chairs in the upper box on the left-hand side, those are the components, subassemblies, and items that go into the construction, the manufacture of the finished goods. So that would be an item that will live in the information system and is generated largely in a product situation, but would be generated by the engineering function to say, here's the stuff that goes into this final product, here are the part numbers, and here are some of the associated pieces of information. All right, so this overall MRP schedule, and this might be a little bit cut off at the bottom for you. And this is part of the documents that are uploaded onto Canvas. There's a set of 4 different things there in a single PDF. So at the top of this is the chair. Again, the green circle is the chair, so that's item H. And as we look through that middle column there, where all the words are, it says gross requirements, scheduled receipts available, etc. We'll talk more about those in just a bit. But this also then has the MRP data file for item G, item F, and then item A at the bottom. And G and F were the 2 subassemblies that we looked at on the previous slide. So we'll go through some of all the mechanics that are here. But let's start with that, the chair across the top. So this says that in week 8 we're going to need 400 or 500 units. That means either a customer wants 500 then, or we need to replenish the forecast in week 8. It also says that we have available to us 50 to sell, so the net requirements are 450, and we'll see another example of this. So 50 we need 500, we have 50, so that makes a net requirement of 450 chairs, and we're going to use that 450 in the other example. So let's jump ahead here. So again, there's the H. The 500 units that come from the master production schedule, and we see that green circle there on the right-hand side. Remember, the master production schedule is expressing the plan in terms of end items for individual end items like the H chair. And then again, we need 450 of those. That's the net requirement because the gross requirement is for 500. We still have 500 or 50 in stock, so we need to come up with 450 new chairs. And those will be offset by 1 week. The blue oval on the left-hand side of this slide shows the lead time as 1. So it's going to take us a week to put those together according to the data that's been put into the system. So those lead time values are fixed. That's something that a human would enter. Like, oh, from this supplier it's going to take about 1 week, or this process is going to take us 1 week. So that's a number that somebody enters into the computer system, and it's going to stay there until it gets changed. Or it's going to stay fixed at whatever that value is, in this case 1. All right, so let's drop down a level. So we're at the bottom left here is the chair. So let's take a look at the F and the G, the two sub-assemblies. And I have them reversed here, G and F. So both of those, they both have a demand for 450, because remember we needed 450 new chairs. So we need enough sub-assemblies to assemble 450 new chairs. So that means we need 450 Gs and 450 Fs. So there's the demand for the 450 Gs, and we're going to call that a gross requirement. Same name of that data field as we had for the end item. So whatever the component is in the MRP system, the gross requirement is the total demand. It's worthwhile mentioning here, I'll probably say it again, that this gross requirement, or let's assume is the total demand for this item. So in this case, our example, G is only going into this chair H, but that component G might go into another product. So at the gross requirement level, that's actually going to aggregate or sum demand across all of the products that G will go into. So in this case, it's only one parent item, H, but it could have multiple parent items. So that row there in the gross requirements could be quite large depending on how many different products that this component goes into. All right, so the gross requirement is 450. Let's do the same math we did on the chair. So the available to us, we have 110 in inventory, and that's what the computer is telling us. So we need some reliability around that 110. We want to know that's correct and feel good about it. So our net requirement is the difference between 450 and 110. That's 340 new Gs to come up with ultimately 450 Gs to assemble into H's, chairs, right? So same deal. These I have a lead time of 2 weeks, so we're going to go back 2 weeks and say, oh, all the stuff to make a G, we need to have available to us now in week 5. So that the math, the other picture there show the very far right-hand column is week 8. A 1 week offset for the chair, that's into 7. A 2 week offset for the stuff that goes into G, so that's going to actually be released then in week 5. So everything we need to make a G is going to have to be available to us in week 5, and we need enough to make 340. So that would be the B and the E and the D. We would have a similar MRP record for those components, and they would have a gross requirement show up for 340 in week 5, and then we would have to offset from there. I have that blue circle going to the F. It's the same logic. I'm not going to go through it, but the same thing is occurring. Now this gets challenging when let's say the customer changes their mind and, oh, I don't want an H, I would rather have your product J, way cooler. I want the blue or the green or whatever it might be. And then the things change. So then if they cancel from an H to a J, then I have to cancel all these orders for these for the G's and the F's. Those are going to change. Some of these orders will end up going to suppliers. Then I have to call the supplier and say, oh, I don't need that F anymore. etc. So remember back in American Connector, when American Connector would change their schedule and then DJC would not. Part of the stability of not changing your schedule is that everybody gets to use the plan and work to that plan. It's not as customer service friendly, but as you can sort of tell from this screen, that much less disruptive to your overall system. Okay, so that's the basic of MRP. It's not very complicated initially. It gets extremely complicated when things start changing, or suppliers don't deliver when they're supposed to, or the customer changes their mind, or we have a quality problem, and then when we thought we had 110 good ones in stock, or we have an IT error, like the data wasn't very reliable. Oh, that wasn't 110, that was really 11 in stock. Oh my gosh, now we have to come up with another 100 units or 99 units to make that happen. So all of this is great, assuming everybody does what they're supposed to do and the information is reliable, then it's easy. However, reality creeps into this, and it's a good planning guide, but there has to be a lot of work to make this happen. Remember also then we have to do a capacity check to make sure, let's say, that we can come up with 340 Gs, product G, in between weeks 5, 6, and 7. Maybe where Gs are made, there's no availability because we're making a bunch of other products then, and that would add another level of complexity to this overall model. All right, that's the basics of MRP. Now, I'm going to kind of take you through the progression of that and show you where that has gone. I mentioned earlier that MRP was created in the early 1970s, and so actually this is a schematic from a company that was from Kirkland, Escom. They're no longer in business, but I had this gentleman come into class years ago and he brought this, and it was just a perfect depiction of sort of what's happening in this MRP system. So I have the two blue circles there. The MPS, the Master Production Schedule entry, then drives MRP, just like the chair, the H, driving demand for its components. So that's sort of at the heart of all this. We've looked at those two orange items before, the bill of material to make the product, and you notice that's in the engineering block there. And then the routing, we've seen that information before. That's down in the shop floor module of this overall system. So one of the things companies started realizing, well, they had in each of these boxes, you can imagine this is a different set of software to solve a particular need, either the accounts receivable or payable, or the procurement need, purchasing, or inventory management, or engineering, or capacity, or shop floor, etc. So what if, or people started to realize, you know, if we looked at accounts receivable, that's money coming in, and we looked at accounts payable, that's money going out, and if you follow the lines, they're all linked to the MPS and the MRP driving those things. If we know inflow and outflow, we have a chance to really look at our overall cash management system. And if we can start to play with this stuff a little bit, it starts to look like an overall business planning system where we can do some simulating to say, what happens if we pushed an order out by 3 weeks or a month? What would happen to our cash position, or if we pulled something back in? So allowed managers and executives to start to simulate their overall model. So guess what? This is called now the extension of MRP, which we had been talking was Material Requirements Planning, MRP, into this new product called Manufacturing Resource Planning, or MRP2. Not particularly great from a marketing standpoint, but they kept the planning words in there, and they kept the acronym as the same, and that actually led to some problems for a while. But this was an overall planning module. Not what they didn't do is rewrite all the software in those boxes, but they would write some software in between the boxes so they could share data and talk to each other. So they still were a bunch of individual pieces of software that were connected together. Now those eventually become ERP, Enterprise Resource Planning, not just Manufacturing Resource Planning. And the Enterprise Resource Planning idea was, hang on, wait a minute, instead of having all those modules with individual data sources, let's make an overall data source, a shared data source, a data warehouse, that different routines to run our business can draw from that shared data warehouse that we don't have to open and update one time. So here's a screenshot of some of the modules that are in the SAP ERP system. And you can see the product development row right there in the middle, the kind of funky looking green. Production planning and manufacturing execution. That looks like some of the stuff that we just reviewed in an MRP system overall. I want to just quickly jump out of this and take you to the SRP page, or the SAP page, not SRP, to show you some of the options they have, their solutions in their SCM modules. So they can do S&OP. We looked at that in the previous video. Manufacturing and supply planning, demand management, service parts, collaboration, a warehouse system, a transportation module, tracking, overall analytics, mobile solutions, on demand, etc., etc. Sustainability is in there as well. So a lot of different ways, that a lot of different little parts that you could add on to your just the supply chain module within your overall ERP system. So quite robust and challenging, obviously, also to put together. So almost done. A couple more slides here just to review the overall planning system. In the middle is where the MRP areas lie. I mentioned the ERP was started in the 70s, and actually a guy named George Orlicky gets a lot of the credit for being at the front of all this. He wrote an original book called Materials Requirements Planning way back when. My friend Carol Patak, who lives in the Puget Sound area, down south end of Puget Sound, she has a company called Demand Driven, I forget the Demand Driven Institute, and she has updated Orlicky's book, and actually the publishers approached her if she would write a new book, and she said, no, I don't want to write a new book. I want to update Orlicky's book in a way that makes sense for today. So I put this link here, and it's worthwhile for you to go to take a look at their little 5-minute overview of what's happening in their MRP module. I've seen Carol present their product and their ideas a couple of different times, and it's quite robust. If you are working in a manufacturing company and are interested in exploring some of the options out there, or developing your own skills, some good resources here. So these links, once you get to their site, you can also check or click on some of the links that are on this screenshot. This is a screenshot. These are not live links, but you can see some of the products they have available and where they're at. Carol is a dynamite presenter, very knowledgeable about what's going on, and I blocked out the date here, but this conference is happening in early November. So that's a quick overview of MRP and the systems within MRP, how it works. Again, not terribly complicated from a math standpoint, but when things start changing, then things get a little more complicated, and you see this notion of the demand driven is how do you build an MRP system that actually is going to be responsive to demand and not just push product out according to the forecast, but also account for demand changes and how that affects the MRP system and all the way through into the trigger points to order new material. Okay, that's it. We'll see you in class in a couple weeks. And again, if you have any questions about this material, post them to the discussion, to the conversation on Canvas. Thanks. See you soon.